My name is RJ Harden, and this is my presentation about the reproduction of the results of the Greenwald and Hall paper, Project 3 for Reinforcement Learning. Greenwald and Hall used a classical reinforcement learning problem called the soccer problem that I believe was first produced by Littman, but in any case it's a grid world problem with 2 rows and 4 columns, a multi-agent problem that's interesting because it has no deterministic equilibrium. Both agents have a Boolean flag has ball, so they have the ability to take the ball from the other agent, and they win or in the game by bringing the ball into their own goal. And if they do that, they get a certain reward, and the other person gets the negative of that reward. So this paper used this particular game because of its lack of a deterministic equilibrium and the fact that Q-learning will fail to converge. But the correlated Q-learning algorithms, there's 4 different ones, but in this particular paper they focused on utilitarian, and 2 others, FriendQ and FOQ, will converge. Was to see whether I could reproduce these converging behaviors. To do this, I implemented the game and used Burlap's implementations of these 4 Q-learning algorithms, and then outputted the results at every 10,000th iteration, and then plotted it in Excel. Unlike the first project, I felt there actually was significant ambiguity in how the paper wrote the details out of how they generated these results for the graphs on figure 3. Particularly, learning parameters were completely unspecified, gamma and alpha, epsilon, etc. And it was unclear on the details about how ball possession actually worked. Who got the ball when one player attempted to steal from the other. So there was a good discussion on this in the Slack chat, and ends up that Littman, who didn't write the original paper, had specified in far more detail in a 1994 paper about how ball possession worked. And so I used those rules, and within it he also talked about some of the tuning parameters, particularly gamma. I think it was a 0.99, but I can't remember. So I used these values, and when all else failed and there was some value that I didn't know how to use, I Googled online for other usages of the algorithms or the parameters, and then use those with examples of other people using these Burlap parameters. Finally, I had some implementation errors that I guess aren't particularly useful or interesting, but there were several problems getting a linear programming solver. The one I used in particular was SCP solver to work, and there were some kind of weird errors that I had to go through. And here are the results. So for the most part, what I observed, well, when playing with the particular parameters of these different algorithms, I was able to recreate mostly the same convergence performance for these algorithms. So for correlated Q, it almost beautifully matches it. For FOQ, I see the results or the change in Q value quickly approach 0, but then some strange spikes here and there where the Q value does jump up. I'm not sure why. For FriendQ, I see exactly, it quickly settles on to an equilibrium. And for Q-learning, I observed just completely divergence. And the paper talks about divergence. That's the whole point of the paper, as I understand it. But the graph that they've provided actually looks to me kind of like it is converging. And so I'm not really sure. But in any case, I believe that these results roughly match and defend the conclusions made by the paper.